Welcome to the manufacturing processes class. So in the casting part, we have studied the various type of pattern terminology there, and what is the heat transfer rate, and what is the time to take for the for the required molten temperature and time to get for the required solidification temperature, and the total time during this casting we have calculated using that formula. Okay, now in the casting process we have some allowances it is required in the casting. So these casting process are called the pattern allowances. So different type of patterns are there. Main pattern allowance is your shrinkage allowance. So why this pattern happens? Because in some time when during the solidification the metal is shrinked. So to that means remove that discrepancy of the shrinkage. So what we do actually we give the pattern. So we make the pattern into a large size so that the shrinkage will be that discrepancy of the shrinkage will be removed. So various type of pattern allowances are there in casting process. One is shrinkage allowance, one is draft allowance, and one is finishing or machining allowance, then shake allowance and distortion allowance. So why shrinkage allowance occurs? So if you see in this figure, shrinkage allowance might occur due to the solidification before it uh, actually reach the solidification temperature. So if you see this one, here reduction is had due to the solidification shrinkage. So what happen if we make the pattern little bit more than the when it is shrinkage also it actually reach the desired height. Similarly here in this figure also you see this one the shrinkage it is occurred due to the solid thermal contraction. Here this one the height of this casting should be this one, but it is actual size is this one. To remove this one, so we generally give the allowance a little bit more. That is called a shrinkage allowance of the pattern. Here the volume also shortens. So this is the shrinkage volume. So that's why patterns are slightly made more than the required shape finish. And this one is the draft allowance. Draft allowance, why it is required? Draft allowance you see. So when the pattern is taken out from the mold cavity, when the pattern is taken out of the mold cavity, so what happen when it is coming out? So if there is no angle like that, the pattern might break. When the mold that means casting might break when it takes out of the mold cavity. So that the pattern or the mold cavity, the casting easily can be removed from this one. So some draft angle is given in this side like this taper. So this is called a draft angle, or you can the taper angle in the sides where it is touching with this the pattern of the mold. So this part actually we can give this one. We make some angle. So in this part of the below part also, this one some draft angle. Okay, this part it is also made like this. So because leading edge this might break, to remove this one we are giving generally the draft allowance. So this taper angle is called a draft angle. It depends on the molding types of the what type of molding, height and complexity of the pattern. Then finishing or machining allowance. So what is finishing or machining allowance? Then when during the time of casting, the surface which is produced may not be proper finish because due to some dimensional deviation or the improper finishing during the casting process. So to avoid this, casting product is generally machined together in some processes like in milling, turning, grinding to remove this improper surface. That means to improve the surface finish. So for this one, the machining or finishing allowance are given. So this allowance is generally added with the basic size of the pattern. Already it is given, because we know that this should be larger, because there will be some dimensional surface finish. So if you remove that one part, the surface finish will be better, all the dimensional accuracy will be better too. That's why we are giving this finishing or machining allowance. So the amount of machining allowance added to the parting, it depends on the one is type of the machining processes, then the types of the material, so what is the accuracy getting, and the molding method. So generally from 2 mm to 15 mm machining allowance it will be kept for the machining allowance. So for large machining allowance, it is maximum size can be given the 15, or the small machining allowance, it is the minimum one is the 2 mm. Then shake or wrapping allowance. So when the patterns are removed from the mold cavity, sometimes it is wrapped into the mold cavity, causing that is it is increases the mold cavity size. That means when it is wrapped, that means some part of the mold cavity it will be wrapped easily by the pattern. So finally what happens, the mold cavity size will be enlarged. So if the mold cavity size we require more metal, then for remove this discrepancy or to compensate for this enlargement, generally with the pattern dimension is reduced, so that it cannot wrap easily to remove the mold cavity. So this type of allowance is called shake or wrapping allowance. Then next one, distortion or camber allowance. As we all know, during the casting processes, lot of thermal stresses or other stresses are generated. So to remove this one, when the mold is the cooling process, the stress will be developed because of the metal unevenness or more cooling or other different phenomena. So what happen, this process can help, that means this process affect in distortion, or might it help might it initiate in the bending phenomenon. So what happen, we can avoid this distortion by in the pattern if we distort the pattern in the opposite direction. So that means it is balanced when this part is, that means some bending is done. So when we are making in the opposite side bending, so this bending will be the balance the bending formed during the stress formation. So the casting part, whatever the produce is uneven. So in the solidification process, it is not uniform, and the thermal stress will be developed in this section. So those castings are the distorted. So for this one, we are giving camber, which provided in the opposite direction. As a result, it will neutralize the bending which is produced during the casting process due to the generation of the uneven stresses and the thermal stresses produced during the casting process. Okay, thank you.